Hi, so this is a MathWatch task that you will have done on the 3rd of June, and it was all about relative frequency and expected outcomes. So I'm going to work through these questions and then I'm going to save this Word document of my writing, and then I'll upload that as well to show my homework, so you can see it in two ways in case you don't have time to watch a full video or you only just need to see one question. So let's go through these first two. I've got all 10 questions on here. Carol rolled a dice 150 times. She rolled a 6 29 times. Use Carol's data to estimate the probability. So when we have an estimate of a probability, that's what our relative frequency is. If we were trying to find an exact probability, we would look at what the theoretical probability, and we would expect to roll a 6 on a dice 1 out of 6 times, so a sixth. But that's not always the case. It's quite close. We'd need 30 to get that. But our relative frequency is the amount of times it's happened, so successes, lots of S's, over the number of trials. So we've rolled a 6 29 times and we've rolled it 150 times in total. So it would be 29 out of 150. This next question is hopefully going to be quite easy for you. You might think, oh yeah, easy peasy. Well, this time we've rolled it 39 times out of a total of 150 times. So our probability is 39 out of 150. A biased dice was rolled and the scores recorded in the table. So bias just means they're not all the same. Estimate the probability that the next roll will be a 4. So again, we need to think, well, a 4, we've done it 8 times. We just need to find out what our total is. So we need to add all this together to find out the amount of times we've rolled it. So I'm going to do 11 plus 22 plus 7 plus 8 plus 13 plus 19, and I'm going to do this in my calculator, but we could easily just do it on paper, just taking our time, and it's a nice number, 80. So that's 8 out of 80, and you might be able to see that that can simplify down to 1/10. If the dice is rolled 400 times, how many times would you expect to get a 2? Well, the probability of a 2 from our experiment is 22 out of 80. And I can have that as 11 over 40 if I simplify that fraction dividing by 2. And what I need to do to find the expected amount of times, I can scale this fraction to be over what I want. So a total amount of 400 times. So how can I change this fraction to make it look like this? Because 11 over 40 means if I roll it 40 times, I get a 2 11 times. So I want to ask the question, well, if I roll it 400 times, how many times am I going to get a 2? Well, this is equivalent fraction work. I've times by 10 here, so I want to times by 10 here. So if we rolled it 400 rolls, we expect 110 2s. Okay, that was question 3, so this is going to be question 4 and then 5 and so on. On a biased dice, the probability of getting a 1 is 0.3. The dice is rolled 150 times. How many 1s would you expect to roll? So 0.3, well, that means 30%, doesn't it? That's a 30% chance of getting a 1. So I need to find 30% of 150. Well, 10% equals to 15. So 30% equals to 45 because we're timesing by 3. So we would expect it to be 45 times, because that's 30% of it, of the times of rolling it. And similarly on this question, how many sixes? Well, 4/5. We want to find 4/5 of 500, and we're really good at finding this. We divide by the bottom, we times by the top, and that's going to get us to 400, because 500 divided by 5 is 100. 100 times by 4 is 400. Question 6. So this question is similar to that, but we just need to do it on each of these separately. So that means 20% of the girls, which is 320, and this is 10% of the boys, which is 250. So let's do the girls first. Well, 10% would equal to 32, so 20% would equal to 64, timesing it by 2. Boys, 10% is going to be 25, and that's all we need to find. So how many are left-handed? Well, we've got 64 plus 25, that's our girls plus boys. 89 people are left-handed. What was that, question 6? Okay, got question 7, and that's question 8. A total of 60 raffle tickets were sold at a school fair. Bethany has a 20% chance of winning the top prize. How many tickets must she buy? Well, if we find 20% of 60, that's going to be the amount of tickets she's got to have a 20% chance of winning. So 10% equals to 6, so 20% equals to 12, so 12 tickets she must have bought to have a 20% of all the tickets. Spinner is shown to spin 300 times, so all of these added together are going to equal 300. That we've saved ourselves a big job there, just by reading the question properly. How many times would you expect the arrow to stop on green if the spinner is fair? Okay, so we don't need to look at our table just yet. Fair, we've got 1, 2, 3, 4, 5 blocks which look to be equal size. So if this is fair, green is going to be 1 out of 5 because it's just one of the 5 sections. Here is actually the actual probability, the relative frequencies of it. So it's not going to be following the 1/5 pattern, but we're going to do it from the experiment. The probability of landing on purple, well, that is the amount of times it's landed on purple out of the total amount of times we've spun it. And if you want to simplify that down, you're not required to in probability, I've said that before. But we could simplify it down to that. So that is the amount of times it's purple out of the total. So I'll write that there. Purple over total. If it's spun another 1,000 times, how many times would you expect it to land on blue? Well, the probability of blue so far is 45 over 300. That is blue over the total. And that is 3 over 20. Or we could say that that is 0.15. If we spin it another 1,000 times, there's another way of doing this expected outcome. It equals the probability times by number of trials. So that would be 0.15 times by 1,000 trials, and that's going to be 150. I'll do one scroll down to write the answer now. So that would be 150 times we'd expect it to land on blue. You could also just find 15% of 1,000. That would give us 150 as well. That was question 8. So question 9, and our final one, question 10. So, first of all, we always just want to look and fill in this table. So we need to do 1 subtract 0.13, subtract 0.05, subtract 0.21, subtract 0.19, subtract 0.3. We could also add all these numbers together. So I'm going to add them together. 0.13 plus 0.05 plus 0.21 plus 0.19 plus 0.3. That's going to give me 0.88. So this number here must make up what adds up to 1, because remember, probability is always what adds up to 1. So that's 0.12. Probability of landing on a 3 or a 4. Well, that's going to be 0.12 plus 0.21, because we're just adding up the probabilities of the 3 and 4 there. And if we spin it 300 times, expected outcome is going to be 3, sorry, I'll do the way I was doing it before. So the probability times by number of trials. So that is 0.33 times by 300. And that is going to give us 99 times. You could also have 100 times. Would make sense as well, because it's estimate, so it's kind of getting roughly close there, but I'd say 99. That's the exact number I got. And the final one. A dice is rolled 50 times. So I know that my total there would be 50. Relative frequency of scoring a 1 is 11 over 50, but that's because we've done the 11 over the total. What about throwing a 4? Well, that would be 9 over 50. How many times would you expect to roll a 5 when a dice is thrown 3,000 times? So the probability of getting a 5 would be 12 over 50. And if we were to simplify that, could write it as 6 over 25, not so much needed. And then the expected outcome is going to be the probability 6 over 25 times by the amount of times we spin it, 3,000. And that gets me 720. How about if it's a fair dice? Well, the probability of 5 when it's fair on a dice would be a 1/6. So the expected outcome for this one would be 1/6 times by 3,000. And that is going to get us 500. So 500 times we would expect it. Okay, that's all the answers for this one.